Alright, today we were talking about the portfolio and stock management system. The team is myself, James-Carl, Tracy Huang, and Dylan Sprague.
Django uses a URL conf module in order to figure out where and what URLs should display. This is usually set in root URL conf variable in the settings.py file, which sits at the root of the project. That will load the appropriate Python module. But how it does this is by running through each of the URL patterns in a list until it reaches the one with a matching pattern, and then once that occurs, it imports and calls the view, which is a Python function with arguments, and this allows us to handle errors well, because you can set up defaults for different kind of mismatches. Moving on. This format, like I said, allows us to handle errors well, and from a performance standpoint, each regular expression is compiled the first time it's accessed, and this makes it incredibly fast. The other thing that this format allows us to do is use YQL and other API data as we see fit, and because of the ability to embed Python, we can put control structures within the HTML page in order to determine if an additional API call needs to be made or an additional query needs to be made, which can save on costs. Although not an enterprise app, it's good to be mindful of enterprise issues. So our users will exist in one of three states. A non-registered guest. This allows you to make use of all of the features, except you won't be saving any information, and purchases are disallowed. The second one is a registered user who will be able to save information about past purchases or past queries, and they'll be able to look at their bookmark stocks and can maybe set up quick links to access specific formulas for analysis. The third one is a customer broker. They'll be making purchases. There'll be a separate module for that. But the broker will just be purchasing through a third party based on information they see fit on our site. Each role will have access to different data models and views, and Django allows for easy manipulation of user roles in their settings.py and using the dispatcher and URL patterns that we talked about earlier. Another note is that, like I said, because we can embed control structures within the HTML, we can manage how those API calls are handled. And this goes along with any other sort of resource that we want to limit, or any other resource that we need to manage wisely. We can do this by embedding any of the Python control structures that we see fit. And then additionally, just the client-server architecture in and of itself will allow us to scale and update our app without any disruption of service. And this also allows us to make access faster by setting up servers in specific locations based on user use. And it also allows us to do heavy computation without needing to have some regard for the user's machine or format computations for personal mobile devices. So that pretty much wraps up our client-server discussion.
Okay, so now we're going to continue with our discussion on data flow. Our app will go through and process data in a number of ways, and without getting into an explanation of a sequence diagram, it basically breaks down to three main steps. We have a feed, which our server will take and analyze, and then basically report that to the app client. So they'll be putting in requests for analysis on certain stocks. That information will come from, the Yahoo API or the Google API, depending on what they specify, and then that will query and just feed that back to the client. And the options that they'll have as far as analysis will be basic, candlestick graphs, basic line graphs, but basically for single stocks, this will be available to all users without the need to register. And then for our registered application users, they'll have access to multi-stock analysis, being able to compare multiple things side by side and looking at various metrics and ratios that would prove useful. And now a quick discussion about how we're going to perform these analysis on the data feeds that we get, and why this is a useful application. So right now, quantitative analysis is fairly esoteric, or only investigated by professionals or people who make a living, or are hobbyist day traders. So what we hope to do is just make those quantitative analysis tools available to everyday users. We do this by using open source libraries like the QSDK, which is the quantitative software toolkit. It uses Python, it uses NumPy and Pandas, which allows us to make use of highly optimized code. And there's also multiple types of visualizers that we can use, and enhance that with HTML5 and JavaScript using the Python templates. It also does some trading simulations, so you can use that if your interest level is at that place. And then another major advantage is that we will provide a nice GUI instead of the command line interface that comes with the QSDK stock. So making it available to non-technical people was a main feature. Some things that we're going to be using are Bollinger Bands. It's a standard analysis tool to determine, just when something's oversold or overbought. That way you don't have too much volatility in your portfolio. And some of the automatic algorithms can act on some pretty much set in stone features of good and bad stock performance. So while not perfect, an algorithm is a much safer bet than sitting by the screen hoping you react in time. So another option that we'll have offered is the ability to set safeguards and limits. That way things are taken care of on that front. And then we'll basically just use, again, basic metrics like the Sharpe ratio or the Sorrentino ratio to keep volatility at a minimum. And then you can also simulate some investment if you have some information and want to put it to the test. This is a good place to do it without needing the technical expertise or programming expertise of using the command line.
So since we'll be talking about database, let's start talking about database types. There are three basic types. And first, this is a relational database, the one that we're most familiar with. For example, there's a SQL Server from Microsoft, and MySQL is open source. Essentially has a lot of features that are very well established. Basically, it just rows and columns in table format and to run queries to get data for application. Also, there's OLAP. OLAP is cube action and dimensional analysis. The drawback of OLAP is that aggregates the calculations, for example, like summations, averaging, they are not available until it's connected to a relational database. So also there's NoSQL. It's gaining more and more popularity nowadays because of the large amount of data we're dealing with. So some of the websites such as like Craigslist and Facebook, they use NoSQL because essentially handle the document-oriented data format as opposed to a table format. And it's user definable, has a lot of flexibility, also can be scaled up horizontal direction, as opposed to a relational database can only scale in a vertical direction. If you want to go horizontal direction, you have to add hard drives. So that's the major advantage of NoSQL. And one of the leading software is MongoDB, which we'll talk about later. So the software frameworks, we're looking at MySQL and SQL Server and MongoDB. And MySQL, as we all know, it basically has a LAMP pack. So essentially has Apache, MySQL, and Python, Perl, PHP. A Linux-based system is open source and has a lot of features, continuously added to it. It's very useful. So it could be one of the candidates for our project. But also there's a Microsoft SQL Server. And this server is a C-based engine. And also recent improvements over C-base in terms of features such as index views and multiple triggers. Those being added actually gain a lot of traction for SQL Server. And later on, we'll talk about more comparison between MySQL and SQL Server. MongoDB is a different type, as we mentioned earlier. It's actually a non-SQL database. So it's document-oriented, it's like a JSON type. And it's more of like you're reading a paper. So it's less structured, but the advantage of it's horizontally scalable. So for our project, MongoDB, it's very useful because it can handle a large amount of data. But the problem with the non-SQL database is that the data integrity is actually compromised because of the structure is not well defined. And for our project, because we are dealing with financial data, which is really the foundation of the financial analysis, all the models we'll be using. If the data integrity is questionable, really the financial model that we're building will become useless for our clients. So because of this, MongoDB probably would not be the frameworks of choice. We'll look at MySQL and SQL Server more closely. So look at the comparison of the different frameworks so in more detail. We can see that SQL Server actually has a lot of features in addition to the ones that we're more familiar with, but also they have the user-defined data types, which now my SQL doesn't have. Also, the distributed queries access data from multiple sources. This actually becomes very useful for SQL Server, because not only that you utilize one data source, you actually look at multiple heterogeneous data source. MySQL is lacking in that regard. For our project, because we are dealing with a lot of different financial models, we'll need to pull also data from different data sources. So this feature provided by SQL Server become very attractive to us. And also the data integrity and accuracy, as we mentioned earlier, is actually it's really it's the nature, it's inherent in the SQL. So either the SQL Server, SQL Server, or the MySQL, they both have this nice feature, the data integrity accuracy there. Well, actually more SQL Server than MySQL. And the MongoDB side, we can see that it's actually lacking in that regard. The only thing that we see that Microsoft SQL Server doesn't have is the cross-platform support. So SQL Server only runs on Windows, which also gives some nice features, meaning that you can actually make a lot of connections like .NET, ODBC, those. It's very nice, but then it doesn't run on the Linux and Windows. Later on, we'll talk about whether it's going to be an issue for our project or not. So, the programming languages, we're looking at SQL, which is pretty standard programming language for database. It's well established and also has very fast aggregate arithmetic calculations, which is very, very useful for the data queries and process. But then one thing that SQL doesn't have is that when it comes to more complex data structures, like for example, mathematical calculations, object-oriented structures, SQL might not be very good. So Java instead is actually very powerful in this regard, because Java is object-oriented programming language and can handle a lot of complex user requirements. So because of that, we want to leverage both, the Java side, meaning that we wanted to handle complex computations because of the financial models that we're dealing with. Some of them are quite complex. If we just use SQL may not be, sufficient. So you want to utilize both. And later on, we'll talk about the connection between SQL and Java. Could be the way to go. And then Python is also another object-oriented programming language gaining a lot of traction lately. But then, given the current state, Python is the database access layer is primitive, which is also underdeveloped compared to Java, and it will limit its use. Another drawback is that the tools, if we have a team developing the same database, the support tools is lacking. It's just not, infrastructure is not there yet. So later on, if we want to develop a database, like a multiple team members involved, it's going to be an issue. So as we mentioned earlier, we'll be using SQL for the database. And then we're going to be looking at Java, Python as well, even though Python has some drawbacks for teamwork, collaboration. But since this project is actually for a small team, so we'll be looking at a Python for this application as well. And also the reason that we have both Java and Python for the database is because we want to access to a wide range of financial models and financial analysis. So this will give us a lot of flexibility. So we're looking at the dashboard. It could be a Java program. It could be Python as well. And the connector will be JDBC or Django ORM. And the groundwork will be MySQL, like LAMP, and Sybase or SQL Server. So whenever we pull the data source from those servers, and we always have the connector there to make it work. So hardware platforms, as we see, that we have Mac, which is very powerful, but then since we're building both web and mobile applications, this becomes a limitation as the availability. It could be an issue here, as the mobile app will actually use Windows to build it. And Linux, as we know, is very powerful, but then the security holes, it could be an issue if it's not configured correctly, and also the rootkit attacks. Windows, on the other end, even though it's more, sometimes it's the speed is not there. But then recently, SQL Server has made some breakthrough to make the speed much faster than before now. And also, Windows has some nice, interface with ODBC and .NET. So Windows, it will be, for our application for this project, it could be enough for our purpose, because security is one of the non-functional requirements we can't overlook. And also we need to build a mobile app, so really that leaves us Windows as an option for the platform.